PNSO has given us many good dinosaurs, and as if to whet our appetite, a few non-dinosaurian ones, including quite a few sea reptiles. And joining that coterie today, we have Evan the Tylosaurus. The name Tylosaurus means knob lizard, and I know some of you from the UK will be smirking, but to clarify, the knob here refers to their elongated rostrum. Indeed, tylosaurines were mosasaurs characterized by this edentulous extension compared to other mosasaurs. Now, Cope originally thought that this toothless extension acted as a sort of battering ram. Now, more on that later. The tylosaurines were some of the largest mosasaurs, and Tylosaurus was estimated to be 12 to 14 meters or 39 to 46 feet long. And this model measures about 38 centimeters along the curve, so for 1 to 35, this represents a 13.3 meter animal, though PNSO does state they used 14 meters. So let's have a closer look. Now, the head of Tylosaurus tends to be pretty triangular, and the slenderness of this one in particular makes me think it might be Tylosaurus napoleicus, but someone will correct me in the comments below. The teeth are very fine, nicely sculpted, though the paint is a little off. Now, there are the pterygoid teeth, as you can see here, which is a common feature in mosasaurs and may have helped secure prey while feeding. And lying on the bottom, you can see what looks like a forked tongue to me, consistent with the Mosasaurus. You can really appreciate the scale detail here. Just look around the lips here. They are so fine and gives you the impression of a really smooth and streamlined animal, as you need for fast swimming. The gums are also very nicely done. Just look at how realistic that tissue looks like, as well as hints of the blood vessels underneath, like the veins. Unlike the Mosasaurus, this Tylosaurus doesn't have an articulated jaw, so you have a permanently open mouth, though the plus side is the lack of any unsightly seam lines. I really like the deep throat here. As for the rest of the body, right away, let's get the ugly out of the way first, because if I didn't address it right now, I'm sure you'll be distracted by it all the time. This seam line. I'm not sure if it's just mine, but in addition, the midline here doesn't align. Now, this thing feels very light, so it might be hollow inside, and I wish it had more heft. I usually find it easy to ignore seam lines, but for this, it's quite difficult. I've had this with me on the table some time now, and over time it's become less obtrusive, shall we say. And quite honestly, depending on the angle of the light, it might not be that obvious, but it's still painful. And the reason for that is ironically because of all the good things I'm about to say about this beautiful model. Starting with the exquisite fineness of the skin. Now, you saw that already in the head. It's a lot smoother compared to the Mosasaurus. Here, without the same kind of glitter and fish skin wrinkling. And while I love that, you can see how here this is replaced by a scalation that is really realistic. Very, very fine. Not the kind of detail you see in a typical model of a sea reptile. It also doesn't have the iridescence or sheen of the helicoprion here. But because of how smooth this is, it still has some kind of a shine depending on the angle of the lighting. Again, just look at the pedals. Such exquisite detail, including the pedal rays. And in the tail, really very fine mesh here. You can tell I'm at a loss for adjectives here. Just look at the fade in the tail here. And that brings me to the second really beautiful thing about this Tylosaurus, the color. Now it's quite similar to the release images, perhaps a bit lighter in the mid-zones here. It's counter-shaded, which is common enough in sea animals. And when you look at this beautiful blend here, I just really love this almost tri-colored banding here. Of course, there are fewer wrinkles on the convex than on the concave side. And here, just look at how naturally the skin creases look. Anyway, back to the color. On the underside, just look at the subtle regional variety. When I first saw the release images, and then I saw this other color scheme from the PNSO Stories on Earth series, I wish they'd done that instead. But now that I have it in hand, there's just an understated and natural beauty about this. And unfortunately, all of that just makes this seam line such a pity, especially if you've got OCD or you're a perfectionist, which I'm not. Really pleased to have this very splendid swimming reptile. Now, speaking of swimming, there's a downward angulation of the tail in mosasaurs, which is sometimes interpreted as bearing a hypocircle tail, seen here for Tylosaurus in Carpenter's 2017 paper on tylosaurine locomotion. Now, this isn't a new idea, since Lindgren et al.'s 2013 paper presented a splendid fossil of a prognathodon that displays not just this angulation, but also the impression of a tail fluke. So tail flukes on a hypocircle tail have been inferred for mosasaurs. It's a rather interesting shape for the fluke here with this indentation. The significance of this impacts the form of swimming it would have taken, and a hypocircle tail is evidence of at least a semi, if not full, carangiform motion, in which the tail does most of the work and the body is held relatively stiff. Now, this idea is demonstrated in the sinuosity of the tail, as you can see above. Now, not everyone agrees with this, and the more traditional view has a single load pedal, which is still a possibility if the flex is at a shallower angle, as suggested by Dr. Mike Everhart, with a 30-degree angle. Dr. Scott Hartman shows this version here, but also proposes a hypocircle tail version with a bend of 40 degrees. Unlike the Mosasaurus, there's no dorsal fin on this Tylosaurus. A dorsal fin would stabilize against rolling. But given the large sizes of the mosasaurs, with generally large surface area flippers, there's a question about the utility a dorsal fin would have. But in this case here, given the small size of the hind flippers on this Tylosaurus, I think one would have been reasonable. Now back to that knob. A few proponents have suggested its use as a battering ram, either of prey or amorous rivals. Lingam Solia in 1992 looked at the internarial bar, which in most mosasaurs is slender and weakly sutured to the frontal. Now what he found in Tylosaurs was that this bar was not only robust and broad, but the suture is interdigitated with the frontal very strongly, perhaps to handle increased shear stresses. It also seems that immature Tylosaurs had more acutely shaped rostra, while mature ones developed the round distinct knob, as explained in Zietlow 2020. I apologize for butchering that name. Now this comes with these two fiddly stands. I still wish they'd done a double on a single base, but it does help create the illusion of floating. So, time for a couple of obvious comparisons. First is the 1:35 PNSO Mosasaurus. Then we have the recent Kronosaurus, unfortunately of a very small 9.5 meter individual. What would be really nice if it had been based on a larger individual? I think we need larger pliosaurs. So that's it for this review. And really, other than the seam and the lightweight, this Tylosaurus is a thing of beauty. In terms of the form, the scale detail and the color, they've really improved their sea reptile offering, the same way they did with their dinosaurs. From PNSO, we now have two mosasaurids in Mosasaurus and this Tylosaurus. We have some ichthyosaurs, and for the plesiosaurs, we have the short-necked pliosaurid Kronosaurus. Now what's glaringly missing are the long-necked plesiosauroids like Plesiosaurus and Elasmosaurus, which I have no doubt will be awaited by many with much eagerness. So come on PNSO, let's give us our Loch Ness monster.